So let's go to, put the pen on, and we're going to go to, what is this section? I'll put it up here so everybody can see what section we're doing. 13.1. Okay, and it's about trig functions. All right, so let's go through them real quick. First of all, let me grab one of these triangles here. What we're doing with this is all about right triangles today. We'll do some, actually, I'm going to copy and paste that. There we go. All right, this is all about right triangles, okay? So there's a nice little right triangle right there. And I'll try to make a little, boop, boop. There we go. All right, nice and pretty. All right, so let's go through it again. We're going to talk about trig functions, okay? You're familiar with this. You remember some of the terminology and stuff. You may not remember exactly how to do this stuff, so hopefully this is just a refresher course for you. It's not meant to teach you, right from the beginning, because it's going to go kind of quick. All right, so let's do this. Let's pick an angle. Let's pick this angle right here. We'll call it angle theta. How's that looking up on the big board? Is that all right? Can you see that? Okay. So we'll call that theta. So if we call this angle theta, you can call it A, B, C, whatever letter you want to use. I'm just going to call it theta. We're dealing with this particular angle right here. And we want to name these other three sides. Now this side right here is opposite the right angle, so it's always going to be called what? The hypotenuse, okay? So I'll just... Now, I'm sure my writing will get better as time goes on. And I always click, there's like a clicker, oh, that's terrible. Let's get rid of that. All right, let's try this again. All right, that's the hypotenuse. I'll just shorthand it, HYP. All right, this side right here. Now, we're talking about this angle. All right, so it all depends which angle that we're referring to. So we're referring to this angle right here. So what's this side right here going to be? This is going to be opposite. Okay, and this angle, or this side down here, in reference to this angle right here, would be the what? The adjacent. Good. So you're remembering some of the words. It's coming back to you. All right. Now we have ratios. We actually have 6 different ratios. We only talked about 3 last year. I'll mention the other 3 for that 6 today, but we're basically going to be dealing with the main 3 ratios that we talked about before. So you remember what they are, don't you? Sine, okay, and then the cosine, and then the tangent. What does this mean? Basically, it's just a relationship between 2 sides of a right triangle. It's just a ratio is all it is. Okay, the sine is not a variable. You can't divide by the sine. You can't multiply by the sine. Okay, it's referring to 2 sides on a right triangle, and it all depends on which angle you're dealing with. Okay, so that angle right here, this angle theta right here, is really important. So if I said the sine of theta, it's saying, okay, I'm going to talk about this angle. I'm going to refer to this angle. The sine refers to a certain relationship between 2 sides. Well, what sides are they? Do you remember what it is off the top of your head? Opposite over hypotenuse. Very good. Okay, so it's the opposite over the hypotenuse. I will get better at this. Plus, I'm standing. Yesterday, I was practicing, and I was sitting. So I wrote a lot better when I sit. All right, so anyway, the cosine of the angle, do you remember that one? Right, it's the adjacent, okay, over the hypotenuse. And the tangent is the? Good, so you guys remember that stuff. Opposite over the adjacent. And we learned a little, I'll tell you what, I'll do this. The sine, this is what I usually do. Sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. And the tangent is the opposite, almost wrote adjacent, over the adjacent. So if you look at it, SOH, CAH, and then TOA, and let's put it up here. And we learn that by what? What's the word? Sohcahtoa. Very good. All right, Sohcahtoa. Now, when I first learned this, I learned this from Mr. McDonald, my Algebra II teacher. He was also my, what's that? Mr. McDonald. You don't know him. He lives out west somewhere. Anyway, he always said Toa Soka, right? So I grew up learning Toa Soka, and then I started teaching, and the kids are like, oh, that's Sohcahtoa, Sohcahtoa. So everybody always taught when they learned it, previous to me teaching it, they always said Sohcahtoa. So I changed it from Toa Soka, which I remember, to Sohcahtoa. But it's the same exact thing, all right? So let's do an example. Let's grab a triangle. Actually, let's grab, I thought I copied and pasted that, but I guess I didn't. Let's try it again. There we go. All right, so let's drag this over right here, and let's make a let's do an example. Let's just do the example right from the book. Oh, I should have showed you the other 3 trig functions. I'll show you those later. Let's do this. They said, this won't look exactly like the example in the book, but it's close enough. And right there. Now, what they're going to do at first, they kind of not lead you into it, but they kind of warm you up a little bit and don't go straight for what we're going to be doing. Like if I wanted to solve for a right here, you could solve for a without using any trig functions. What would you use? You would use Pythagorean Theorem, exactly. So we're not really solving for a. What they're asking you to do, actually this is a little bit different than the example says, but since I've written it down like this, let's do this. They're going to say, what is the sine, and there's a problem on your homework. What is the sine? They might use a different letter, actually. Let's do that. Let's use the letter A. Okay. What's the sine of A? What's the cosine of A? They're not actually asking you at first to find what A is equal to. They're just asking you to find the sine, cosine, and tangent. Okay? So that means you're not... we'll call this A right here. We'll call that angle A since that's little a right there. Okay? So that's what... If it's labeled like this, then that's what we're trying to do. We're not trying to solve for A, we're just trying to solve for the sine of A. This is very simple. Some people in the past, they make this way harder than it is. This is like really, really super easy. So the sine of A, you just take a look at angle A, which is this one right here, and you have to find, what's the sine? It's the what over the what? Opposite over hypotenuse. So it's this over the 8. Well, we don't know what A is, so we're going to have to find A. So we come over here and let's find out what A is equal to. So that would be, let's use Pythagorean Theorem just like we said. So you know what that is. So A squared equal, oh, I put 64. I should have put 8 squared. I kind of got ahead of myself. All right, so what is it? It's 64 what? Minus 25, and what is that? And you take the square root, right? Get rid of the square here by taking the square root. What's that? 39, is that right? Yep. And the square root of 39. So we'll come over here and we'll say that that is the square root of 39. So that's the number we're going to use. We're going to use the square root of 39. So if I said what's the sine of angle A, you say it's the opposite over the what? Hypotenuse, okay? So it's the square root of 39 over what? 8, and that's it. That's what the sine of A is. I'm not asking you to solve for A. I'm just saying what is the sine of A. That's it. That would be your answer for the sine of A. What about the cosine of A? That would be the what over the what? Adjacent over hypotenuse. So that's 5 over 8, and that's it. That's all you got to do. All right, what about the tangent? What's the tangent? Opposite over adjacent. So the opposite is square root of 39, and the adjacent is 5. And that's all you got to do. Pretty simple, isn't it? Okay.